So in this question we want to find the solutions to this quadratic congruence. X squared plus 5x plus 1 is congruent with 0 modulo 13. Now first things first, 13 is a prime number, so we can go straight away in to try and manipulate this to try and get our solutions. Now one technique I like to use in these questions is to take the square of the left hand side. So x squared plus 5x plus 1, let's first of all, because we don't want any fractions in modulus calculations, so let's make this an even number with modulus 13. So 5x modulo 13, we can add 13 to get x squared plus 18x. So we can manipulate that in that way. So let's go here. X squared plus 18x plus 1 is congruent with 0. And I'm just going to write modulus 13 like that. So now that's all well and good. So now let's take the square of what we got here. So take the square of that. We got x minus 9 squared. And then because we got minus 9 squared, we've now got an extra 81 inside here. So we need to subtract that. So minus 81 plus 1 is congruent with 0 modulo 13. Okay. So now let's simplify this up a little bit and bring it onto the other side. So now we've got to x minus 9 squared is congruent with, well, minus 81 plus 1 is minus 80. Bring it onto the other side by adding 80 to both sides, we get 80. So modulo 13. Okay, so now we've got a square on this side. We want to bring this down and see what we can do with it. To the lowest number, modulus 13. Well, 6 13s are 78. So this is congruent with 2 modulo 13. So let's rewrite that. So x minus 9 squared is congruent with 2 modulo 13. Okay, now we can keep adding 13 to this to see if we can get a square number, but there is a much more efficient way of doing it. Is first of all, let's find the quadratic residues of 13. So quadratic residues of 13. So QR of modulus 13. So they are, so make a set of these numbers. 0 is always included. And we've got 1, 3, 4, 9, 10 and 12. So there are quadratic residues modulus 13. Obviously 0 is included, but obviously if that's congruent with 0, there's always a solution. So now quadratic non-residues. So the quadratic non-residues, modulus 13, that will give us, so basically there'll be a set of 6 numbers, just like these, but the ones missing from 0 to 12. So then we've got 2, 5, 6, 7, 8 and 11. So that's our set of quadratic non-residues. Okay, so now let's have a look at what we've got. So we've got a square number here is congruent with 2 modulus 13. So we can see that 2 is a quadratic non-residue modulus 13. So what we're saying is here now that this will have no solutions. So there is no solutions. Now we could have gone a different way, just to be sure. Instead of adding 13 to this, we could subtract 13, because that would also give us a negative even number. So then if I did that on the side here, I would have x squared, take off 13 from that, that would be minus 8x plus 1. Let's write my x a little bit better. It's congruent with 0, and we stick with modulus 13. So take the square of this one. We've got x minus 4 squared. Magic number will be minus 16. So minus 16 plus 1 congruent with 0, modulus 13. And then we've got x minus 4 squared. It's congruent with minus 16 plus 1 is 15. So 15. And 15 is congruent with 2 modulus 13. And we can see here also this is going to yield the same problem that we got here. So we can confirm that this equation here, x squared plus 5x plus 1 congruent with 0 modulus 13, has no solutions. Okay.